Hello, physics students. This is your friendly physics teacher. I'm going to walk you through how to analyze video that you took of a moving object. And Capstone software does a pretty cool job tracking the object in the video, and then you can display the x and y coordinates in a number of displays, but primarily the graph display. Before we get started, I thought I'd play a little ditty. For entertainment value. All right, so let's get started. This is my desktop. Let's launch Capstone. And here's the welcome window. It does a lot of stuff, so don't go crazy clicking everything just yet. And if you ever mess up, just restart it. Start over. Erase the board, as they say. All right, on the right-hand side, displays list, which I'm going to focus most of our attention here. I'm going to bring in the video that was shot on a beautiful fall day a couple of years ago on the front campus of Mercersburg. I'm going to double-click on video analysis, okay? And I'm going to open movie file, locate the file, just the movie that was captured on a phone, and then subsequently shared to the desktop. All right, I'm going to resize this talking head and hide up here in the trees. And here we go. There are two interesting things that show up when you bring your video in. One is the coordinate tool. This is kind of that X and Y axis that we can place anywhere in the field of view. I'm going to line up the bottom of the meter stick with the X axis. Okay. And then the most important tool of them all is the calibration tool. I'm going to grab the bottom of the calibration tool, and notice that nifty magnifying glass, and I'm going to position it at the bottom of the meter stick. And I'm going to position the calibration tool to the top of the meter stick. Okay, just like that. All right. Now, the video is calibrated in terms of the relative scale. So everything's scaled to 1 meter, and that's the reason for picturing a 1 meter stick in the video. All right. So let's start targeting, tagging, tracking, however you want to call it. They call it tracking the object as it's being tossed back and forth between these two physics students. Okay. Now, the upper menu bar has quite a few features. Don't just touch them yet, but I'm just going to show you how we can get started with tracking this ball. Before we do that, let's advance the video to the point where the ball is just left the hand. So the video control bar down in the lower left-hand corner, I'm just going to click, the forward frame by frame arrow, and as soon as the ball leaves the person's hand, it looks like it left there, but I'm going to make sure it's clearly has left the hand. Now, with the ball just leaving the hand, I'm going to take my cursor and put it right in the middle, and I'm going to click once. And notice that I've got a red crosshairs on that first ball, and then the frame advanced. I'm going to take my cursor, click again, and I'm just going to click the middle of the ball each time, and notice that those crosshairs are showing the position of the ball frame by frame. And the amount of frames that a phone will take is somewhere between 24 and 60. I'm not sure exactly how many frames this video is shot, but the distance between them in time is somewhere between, a 40th of a second, let's say, just on average. All right, just clicking away, making sure that my cursor is right in the middle of the ball, okay, for accuracy's sake. All right, and I'm not going to tag the ball. Okay, this is the last time I tag because it looks like it hasn't quite been caught yet. All right, so there's the position in X and Y of the ball in that vertical plane, having been calibrated to 1 meter. All right, now let's take this data and display it. Over on the displays toolbar, you have graph, table, any number of displays, but we're going to choose graph, and I'm going to double click once. Okay, I just brought in a graph. I'm going to double click second time, and now I have two graphs. And the reason why I got two graphs is the purpose of this activity is to display the x-coordinate of the projectile's velocity and the y component of the projectile's velocity. Because so what we know about projectile motion, you should expect that the x component of the velocity is constant, while the y component of the projectile's velocity is changing continuously. All right, let's activate the first graph display that I brought in. Hover your cursor over the label of the y-axis, and you're going to select, in this case, object 1. You may have more than one object because you've for every attempt that you track that ball, it'll create successive object numbers. I've gotten up to 12 at one time because I was, messing around and trying to get it right. But here, I started with a fresh document, so I should only have like one object. But you could have object number 2. So I'm going to pick object 1 and display the x coordinate as a function of time. There it is. It's not, the graph hasn't been scaled yet, but I'm going to click the upper left-handmost tool on the toolbar on that graph display, and it says scale axis to show all data. Wow, look at that. I'm about to fall over it. That's cool. So notice that the x position of that ball is moving technically across the video display at a constant rate. So it's moving to the left incrementally in equal intervals of time. That's cool. Now, we can then assign an equation of fit, and it seems that linear is the most appropriate one. So I'm going to select linear fit, and oh, look at that. Slope is negative 2.79, which is telling that the ball is traveling to the left. And if we're to take the idea that the horizontal component of projectile's velocity is constant, that ball is moving in the x direction, negative 2 meters, 2.79 meters per second. And then it says it starts at 0 speed, which is it's moving on the slow side. At least that's what I'm imagining. But it's the initial position is 0. That was like one frame after it left the hand. All right, let's go to the y component of the ball's tracking, and hover once again over the y label, select object number 1, and now the y component, says y object number 1. Okay, comes in, and let's take the upper, on that lower graph display, upper left-hand button, which is the auto scale. Look at that. Looks like a parabola to me. And notice that in the video, that's a parabola as well. But that's y is a function of x parabola. The graph display, that's a y position of the projectile velocity with respect to time. All right, let's apply the appropriate equation fit, which tends to be curved for the y component. I'm going to pick quadratic. Okay. And let's take a look at the, oh my gosh, look at that. The coefficient of A, which is expected to be minus 4.9, and sure enough, it is. As many times as I've done this, I haven't gotten exactly minus 4.9, but it must be my lucky day. And if it's my lucky day, it's your lucky day, because we're all in this together. All right, so there you have it. Now, there's quite a few rabbit holes you can go down in configuring these graph displays and these video displays. And if at any time you get confused or lost, just quit the application and discover for yourself all the nuances, and maybe refrain from clicking something you didn't want to click in the first place. Now, I want to remind you of something. It does have a go back. Okay, you can always go back and redo something, or delete something and reassign it. And I'll let you discover that, because I don't want to make this video. It would take days to explain everything this software does. All right, have a nice evening and happy tracking. And I'll give you an assignment to track the motion of something. Most likely it'll be a book sliding down an inclined plane, and then some questions assigned that'll go along with that assignment. All right. Take care. Have a good evening. Oh, outro music. Okay. Let's see. What would be a good outro? Free Falling, I think, by who's that famous musician? I think you know who he is. But that's appropriate for this assignment. All right. Take care. That was minor. All right. Have a good evening.